Hi, welcome to my video sessions again. Today we will talk about the other type of AC to AC converter that's called integral cycle control. In the previous videos we have shown you a simulation and experimentation for one of the techniques that is used normally in AC to AC converter, that's called AC phase voltage controller. In that method, we have used cutting of portion of the input signal so that the RMS value can be changed accordingly, and then you can change the dimming of the light or the light intensity of the light bulb or the speed of the motor accordingly. But in this technique, as we have demonstrated in the Proteus simulation in previous videos, we have shown that what you can do, that you can eliminate one or two complete cycles so that you can also get a variable RMS value across the load. Then you can change the light intensity across the light bulb, and also you can change the speed control of the motor accordingly. So what we would see now, it's a practical demonstration for that idea. So as we can see here, a quick review, this is the Arduino, which is the digital controller for the circuit, and this is the power circuit. We have used the triac, and we have used three buttons. That button will eliminate or minimize the number of cycles on, and this will increase the number of cycles on actually, and that one will give you the maximum cycles across the loads. Now let's start and see how can we operate this circuit. So as we described, this button will increase the cycle. So basically it's off right now. So I will press the button once, and as you can see here, this is one cycle has gone through the triac, which has increased the light intensity from off to on, and you can see the flickering on that light bulb because only one cycle has gone through out of 5. I have used a period of control that is related to 5 complete cycles. So if you can see, this is 1 out of 5 that is related to 20%. As you can see here, these are the pulses that is going from the Arduino to trigger the triac. Now let's increase the number of cycles by pressing the button once again. So this is 2 cycles on out of 5, which is related to 40% of the full scale of the light intensity. So the light intensity is increased as well. Let's press the button again. Now 3 times we've got 3 complete cycles on and 2 cycles off, which is related to 60%. The number of pulses also coming out from the Arduino has increased. The 4th time we have 4 complete cycles on and 1 cycles off. The light intensity has increased. The flickering is somehow a little bit lower. Now the maximum or the full scale we will have when we press the button 5 times. So this is the 5th pulse, or the 5th cycle is on. So now we have got the complete cycles on, and the light intensity has increased into its maximum value, and there is no flickering at all. Now we can improve the performance of such circuit by modifying the control period. For example, in this case we have used only 5 cycles as a complete control period, but what we can do, actually, you can increase the control period up to 10 cycles or 20 cycles. So if you remove 1 out of 10, which is 10%, or let's say 1 out of 20 cycles, which is going to be 5%, this will give you better performance and better precise control either to the dimmer circuit or to the motor. In the next video I will show you the same circuit applied to a motor, which is a universal motor that we have already used in a previous video by the other